Here's the graph of the information here with number of years since 1990 along this axis, and then cost in thousands of dollars along the vertical axis. So there's a snapshot of that information given what we were given. So here's a question that we're going to ask you in this section. So that's starting in 1990. 10 years would be 2000, 2010, 2014. So here's a good question. And this is actual data, by the way. A study given by someone a long time ago, or a few years ago anyway. And so in 2014, if we used just this data here, what would be a good 2014 estimate for the average tuition for all your colleges? The average tuition here. What would be a good 2014 or a 24Y value estimate here? So here's a question. Would it be here? Would that look like it would be appropriate according to the trend and the dots there? Hopefully you're thinking no. How about here? Let me show you here on the same lines. How about here? Hopefully you're thinking no. How about up here? Hopefully you're thinking no, that's too high. But the trend is following this here at my pencil line, so maybe somewhere in here, I don't know, let's circle that guy. Hopefully you agree. That's the 24 line. Okay, so maybe a good estimate would be, I don't know, 21,000 if we were going to follow this trend. So this is the idea of linear regression here that I want to get into. It is approximating or assuming, or I'll say it this way, approximating this data with a linear function. And with that linear function, we can create a symbolic rule that relates C and Y, and then use the symbolic rule to make predictions like we did in our last section. But the question is, which line do we use? What linear function should we use? Or graphically, which line would best fit this data here? Is it the first and second dots? Would we use the first and second dots to formulate our line? You may be thinking no. Some of you may be thinking, well, should we use the first and last data points to formulate our line? But you can see this kind of neglects these. If we use the first and second, it would still kind of neglect the rest. Do we use the second and the second to the last dots? Is that a good estimate? Well, we can go on and talk about and argue, but we have accepted a mathematical way is to create a line in which the distance, or the average distances from the dots to our line, is the shortest, the average distance. And what we call that line is the line of best fit. And it's a line that would pass through, if you will, as close to, if you will, as all the points possible. Close to as many as the points possible, and it would be a line that looks something like that, just so you know. Kind of take the average distance, or actually we do take the average distance here between this line, and we're looking for the shortest average distances. So that's what we call linear regression. So what we're going to do here is I'm going to pencil in my line here, what I think is the line of best fit, what appears to be the line of best fit. And then two things here. We're going to formulate the linear equation of this line, and then use this line to predict future values. And that line looks like it's going to go through that dot we said it would. We'll see. So here's the goal of this section again. Come up with the linear symbolic rule for this line, and then answer questions and make predictions. So we're going to show you how to do that in your next video.